Hello guys, welcome back. In this video, I will discuss about the fundamentals of Docker. This video will be a benefit to the people who want to learn Docker from beginning. In the fundamentals, we will discuss about the comparison of traditional infrastructure versus virtualization versus Docker containers. We will see what are the issues we face in traditional infrastructure, and we also see what is the current approach. Then we will see the Docker architecture. Afterwards, we will see how to install Docker on our Windows. Then we will see how we can create account in Docker Hub so that we can publish or push our Docker images on the Docker Hub. Then we will pull the images from Docker Hub into our local machines. We will run the Docker images and create containers. We will see how to list all the containers, how we can go inside the container, how to start, how to stop, how to restart the containers. Then we will see how we can remove the containers, how to list all the images, how to remove the images. Then we will see how to build images from Docker file. Uh, then we will see how to publish Docker image from our local system to the Docker hub. Let's begin with the comparison of traditional infrastructure with virtualization with Docker containers. Traditionally, applications were deployed on physical servers by organizations. On the physical server, we were installing operating system like Ubuntu, Fedora, Windows, etc. And on top of that, we are installing binaries and libraries which are required to run the application. After installing binaries and libraries, we are installing our applications. This approach, while simple, had many limitations like time consuming. While installing all these things on each server, it will take a lot of time. We face compatibility and dependency issues. Suppose there is an upgrade or any patch released for operating system, then there might break libraries and dependencies. Then we need to figure out the libraries and binaries which got break and we need to upgrade. This will also take a lot of time. Inconsistency across different environments. Suppose you have multiple environments like dev, QA, staging, and production. We were facing inconsistency across different environments in traditional approach, and we were also facing overutilization by one app could crash the entire system, and it's also expensive to maintain physical servers. The next approach was virtualization. Virtual machines provides an abstraction of the physical hardware. On physical hardware, we are installing host operating system like Fedora, Ubuntu, Windows, etc. And on top of operating system, we were installing hypervisor. A hypervisor allows multiple virtual machines to run on a single server. So this is one virtual machine and this is one virtual machine which is running on single server. Each virtual machine has a full copy of operating system. We are installing guest operating system. Then we are installing all the binaries and libraries required to run the application. Like this, we have multiple virtual machines running on the single server. This approach has some benefits like better utilization of resources than traditional methods. Applications are isolated. So this application will depend only on the guest operating system inside this virtual machine. And this application will depend only on the libraries, binaries, and guest operating system of this virtual machine. It has some drawbacks also, like OS images are heavy. Operating system will be in GB and it will slow up the boot up process, and we cannot port our application, and it also get expensive in maintaining the infrastructure. Then came the container deployment. Here we have basic resources like hardware and operating system. And then instead of whole operating system or virtual system, we will have a platform called container engine like Docker, on which applications and binaries libraries are packed together in a container. Containers are nothing but a package contain all the files required for an application, so that application can run across platforms such as desktop, data center, and cloud. Each container runs as an isolated process while sharing the same OS kernel. Benefits of using containers over traditional approach: containers are flexible and they are light in weight, so they can quickly boot up. Containers are highly portable. We can port this container and can deploy into another machine. Isolation. As we can see that containers are a package of application and binaries and dependencies. It will not affect the other containers. If this one get crashed, it will not affect the another container. And it's also inexpensive comparing with other approach, and they are highly scalable. Let's see the Docker architecture. In this section, we will discuss about the Docker architecture. The architecture used by the Docker is a client-server model. When building, running, and distributing the Docker containers, the Docker daemon and Docker client communicate. There will be a remote connection between Docker client and daemon, or they can operate simultaneously on the same system. A unique socket or a network is used by the Docker client and daemon to communicate with one another using REST API. What is Docker daemon? Docker daemon manages all services by talking with the other daemons. It handles Docker objects such as images, containers, network, and volumes. What is Docker client? Docker users can interact with their containers via a Docker client. The Docker command makes use of Docker API. The Docker client can communicate with several daemons. When a Docker client runs a Docker command from the Docker terminal, then the terminal sends instructions to the Docker daemon. Docker daemon gets those instructions from the client in the form of a command and a REST API request. The primary goal of Docker client is to provide a way to direct pull of images from Docker registry and run them on the Docker host. Client commonly use the commands docker build, docker pull, and docker run. Next, we will see what is a Docker host. A Docker host is a machine that is responsible for running several containers. Its components includes Docker daemon, images, containers, networks, and storage. So from here you can see Docker host contains Docker daemon, images, containers, network, and storage. What is a Docker registry? A Docker registry stores all of the Docker images. There is a there is a public registry which is known as Docker Hub that can be used by anyone. We can run Docker pull or Docker run commands to pull the necessary images from our configured registry. Images are pushed into the defined registry using the push command. Let's see what is a Docker image. A Docker image is a template that contains the instructions for creating a container. It includes the application code, dependencies, and configurations required to run the application. Images are stored in a Docker registry such as Docker Hub and can be pulled down to local machine to create a container. Let's see what is a Docker container. Containers are created from Docker images. A Docker container is a runtime instance of a Docker image. We can start, stop, delete, or relocate containers using the Docker API or command line interface. A container can access only those resources which are defined in the image unless additional access is defined during the building of an image in the container. This is the Docker architecture. In the next section, we will see how to install the Docker on our Windows. In this section, we will see how to install Docker. Installing Docker is a straightforward process that varies depending on your operating system. Here in this website, docs.docker.com, you will get all the steps for popular operating system. Here you can see you can download Docker Desktop for Mac, Docker Desktop for Windows, and Docker Desktop for Linux. I am going to install Docker for my Windows, so I am opening this page. As per your requirement, you can read the system requirements and install the Docker. I am going to install Docker for my Windows. Click on this button. Here you can see Docker has successfully downloaded. Go to the downloads folder and double click on this application. You can see that installing of Docker has been initialized. Click on OK. Here you can see it is unpacking all the files to install the Docker. Here you can see Docker got successfully installed on our Windows. Now it is asking us to close and restart our system. After installing Docker and restarting our system, we need to check something to verify whether installation has been done successfully or not. For that, open CMD and type a command docker hyphen hyphen version. Here you can see Docker version is 27.0.3, and on the desktop you will see Docker icon. Now start the Docker. Here you can see Docker is starting. Here you can see Docker is successfully started. If you want to get the detailed information about Docker, including the number of containers, images, etc., there is a command docker info. This will give you the detailed information of our Docker. Here you can see there is 0 containers running and 0 images. Like this, we can install Docker on our Windows.
In this section, we will see the process of creating a Docker Hub account step by step. Navigate to the Docker Hub website at hub.docker.com. When you visited this link, you will see a Docker Hub homepage with options sign in and sign up. Click on the sign up button in the top right corner. You will be taken to the registration page. Type the email from which you want to create Docker Hub account. After providing email, type a username. This username should be unique. Then after username, type the password. Then click on sign up button. It will ask you to sign in with the email address or username. After providing the username, click on continue and provide the password. After providing password, click on continue. After successful sign in, Docker Hub will send you a verification email to the email address you have provided. I have already opened Gmail and you can see I received a verification email from Docker. Click on verify email address. After verification, it will activate your account. From here, you can add your profile picture and bio to your account. Go to the home page. Here you can see hands-on guide to start with Docker. If you click this, you will get a step-by-step guideline how to set up Docker desktop, how to run your first container, how to build your image, how to publish your image on Docker Hub. I'm going back. Down you will see a billing option. Click on that. On the billing page, you will see billing options Docker Personal, Docker for free. Click on Docker Personal Buy Now button. From here, you can purchase your subscription based on your requirement. I am going with personal because it's a free. In the personal, there is some limitations like we cannot create private repositories and the limitation of image pools is 200 per 6 hour, but we can create unlimited public repositories. Click on continue with personal. Like this, you can create your Docker Hub account. After creating your Docker Hub account, Go to the hub.docker.com website. From here, you can create your repositories. You can find basics and specific guides of Docker, and below you will find container images. In this section, we will see how to pull Docker images from Docker Hub and how to run images to create a container using that image. Now, to download image from Docker Hub, we need to type the command docker pull repository name and the image name along with the tag name. For example, I have already created an image in my Docker Hub account. Now, I want to pull this image. Copy this command, go to CMD and paste this command. Here you can see the status downloaded newer image for saphosis/saphosis colon 2.1.2 release. Docker pull command is used to download the Docker image from Docker Hub to your local machine. Let's see how to check the downloaded images. For that, there is a command docker images. This command is used to list all the Docker images available on your local machine. Let's see that docker images is the command. Here you can see Docker images giving the output repository, tag, image ID, created and size. Image. Let's see how to run the downloaded Docker image. This is the command to run the Docker image. Let's see with an example. I am copying this command and in CMD I am pasting this command. So this command is nothing but docker run. It will create a new container and name is nothing but my app. I am giving a name, my app to the container which we are going to create, and P is nothing for port. This first port is for host machine and the second port is for container. D means it is going to run in the background and we are giving the repository and the image name. Hit enter. After running the image, we got the container ID. This is the container ID. Let's see how to access the application. Go to your favorite browser and type the URL. Here you can see greetings from saphosis.com. It means that container has been created and it got deployed. Let's see how to list the container. There are three commands to list the containers. Docker ps will display only the running containers. It will show the container ID, image, command, created time, status, ports and name. Docker ps-a command displays all containers including the stopped one, and docker ps-a-q it will display all the containers including the stopped ones, but it will only show their ID. Let's see this one by one. First command is docker ps. Here you can see that container ID is this, image, command, and when it got created 2 minutes ago it got created and its status is up, Ports it is showing 8080 to 8080 and its name is my app, which we gave in the docker run command. So my app is our container name. The next command is docker ps-a. As of now, as there is no stop container, it is showing only the one which is running. Next command is docker ps-a-q. It will give only the container ID of the containers, including the stopped ones. Let's see how to connect to the container terminal. The command to connect container terminal is this one. So copy this and paste it in CMD. You can see that when we run this command, it is showing a shell which is inside the my app container. From here, we can execute the commands or we can inspect the containers file system. Let's see using ls. ls command will list all the files and directories. To come out of the container terminal, we need to type exit. Let's see how to stop the container. To stop the container, we need to type the command docker stop container name. It is used to stop a running container. Copy this command, go to CMD and paste the command. Hit enter. Now you can see I stopped my container. We can check using docker ps-a. You can see that here in the status it is showing exited. Stopping a container does not remove it. We can restart it with the docker start with the command docker start container name. So for example, docker start my app will again start the container. Let's see using the docker ps-a command. You can see that in the status it is up now. Now let's see how to remove container. We can only remove the stop containers. If the container is running, then first we need to stop the container using the docker stop container command. Removing a container does not remove its image. The image will still be available locally. Command to remove the container is docker rm container name or docker rm container id. Using any one of these, we can remove the container. Let's see with an example docker rm my app. So when I run docker run my app, it is showing that the container is running. That's why I can't remove. So first we need to stop this container. Docker stop my app. So it's a typo mistake. Docker stop my app. I have stopped the my app container. Then now I can easily remove this container. Docker rm my app. Now you can see it doesn't give any error. Let's see any container is there or not. Docker ps-a. You can see that there is no container running. Let's see how to remove image. For that there is a command docker rmi image name or docker rmi image id. Here you can see we have removed our container, but when we type docker images, we can see Image is still present. So to remove this image locally, we need to give docker rmi and the image id or image name. So now what I will do is I will take the id and hit enter. You can see that it got deleted. Now run again docker images. You can see there is no image as it got deleted. Like this, you can pull your docker images from docker hub, run the docker images and deploy the container. In the previous section, we have seen how to pull docker images from docker hub into our local machine, then how to run the images, how to go inside the container, how to list all the containers, how to list the images. Then we have seen how to remove the container, how to stop the container, how to start the container. Then we have seen how to remove the container, and we have also seen how to remove the images. In this section, we will see how to build image from Docker file and publish in Docker Hub. For this, what I will do is first I will take a base Nginx image and run it locally. When we visit the local host and the port number, we will get the default Nginx page. Next, we will create index.html page and Docker file. In Docker file, we will copy our customized index.html. Then we will create an image from Docker file and run it on our local machine. After running on our local machine, we can see our customized index page when we visit the localhost 8080. After that, we will push the newly created Docker image to Docker Hub. Let's begin. First step is run the base Nginx container locally. This is the command opencmd. Paste this command. Here you can see that after running this command, it is unable to find image locally. So it is pulling the image from Docker Hub. Here you can see the status downloaded newer image for Nginx. Let's see whether container is running or not using the command docker yes. Here in the status you can see it is up. It means our container is running. Now let's see what we are getting in the browser. Localhost 80. You can see this is the default Nginx page. Now I will create index.html file. Now I will copy this code into index.html file. Save this file. Then next step is we need to create a Docker file and copy our customized index.html. In the same folder, I am creating a new Docker file. Here in the Docker file, we are creating a new image from the base image Nginx, and we are copying index.html file into the user share Nginx HTML folder of Nginx, so that whenever we visit localhost port 80, then we will see our customized HTML page. Save this file. Now let's see how to build a Docker image from Docker file and how to run locally. This is the command to create a Docker image from Docker file. Hit enter. You can see that building a new Docker image has been initialized and it got successfully created. Let's see with the command Docker images. Here you can see that our new image has been created successfully. It is created 20 seconds ago. And the base image is Nginx. Now let's see what are the container running. Here you can see Nginx container is running. Now if you want to run our customized image, then we should stop the old container, or you can give a new port, but I want my newly image to be run on the port 80. So first I will close the Nginx container. For that there is a command docker stop Nginx. We need to give the name of our container. Docker stop my Nginx default. Now let's see the status. Docker ps. Here you can see there is no container running. Let's see with docker ps -a. It will list the stop container as well. Here you can see the status is exited. It means container is stopped. Now I will remove this container completely using the command docker rm and the container name, that is my Nginx default. Now let's see with the docker ps-a command. Here you can see there is no container as of now. Let's see how to run our newly created image. For that, this is the command and hit enter. Container has been started. You can check using the docker ps command. Here you can see that status is up. It means the container is running. Let's see the docker images. You can see our newly created image is also there. Now let's go to the browser and check the status. Here you can see our customized index page. Now let's see how to push the Docker image to Docker Hub. First, you need to have your Docker Hub account. We have already seen in the previous sections how to create a Docker Hub account. You can go and see how we have created a Docker Hub account. Now to push the Docker image to Docker Hub, we need to first tag the we need to first tag our image. So this is the command to tag our image. Paste this command. First, let's see what is the Docker images. Now I will paste that command. Here you can see v1 dash release our new tag. After tagging our newly created Docker image, then we will push our locally stored Docker image to our Docker Hub. For that, there is a command. Here you can see after running the Docker push command, it is started to push our locally stored Docker image to the Docker Hub account. Here you can see v1 release. It means it is successfully pushed. Let's see whether it is there on our Docker Hub account or not. So this is my Docker Hub account. Go to the repositories. Here you can see our new Docker image. It is pushed a few seconds ago. This is how we can create Docker image from Docker file and how to push Docker image to the Docker Hub account repositories.
Hope you like this video. Please like, comment and share this video. Thanks for watching.